Upsilon Andromeda, a world of fire and ice. Upsilon Andromeda is another exoplanet that is probably tidally locked to its host star, completing an orbit in just under 5 days. What makes this planet, which was previously known as Sapphire, an extreme world, is a radical difference in temperature between its dayside and nightside. Whilst the dayside experiences temperatures as high as 2,912 degrees F, 1,600 degrees C, the nightside is considerably cooler, reaching temperatures as low as -4 degrees F, -20 degrees C. This means that passing the hemisphere of this world could be considered equivalent to jumping into a volcano. While this is by no means the only tidally locked hot Jupiter, the others we have discovered don't seem to feature such radical disparities in temperature between their star-facing and star-ignoring sides. The reason this exoplanet experiences such a radical difference in temperature could be due to the tremendous size of its parent star Upsilon Andromedae, or the fact that the star possesses a hot spot almost directly overhead this exoplanet. HR 5183b, the Whiplash Planet. In terms of exoplanet discoveries, HR 5183b, a super Jupiter 3 times the mass of the solar system's largest planet, is unique as its orbit is highly eccentric, both literally and figuratively. While most planets trace out a mostly circular orbit, this gas giant traces out an egg-shaped orbit around its parent star HR 5183, according to astronomers at Caltech. Astronomers discovered the exoplanet by the tiny wobble its gravity causes upon its parent star, which in turn causes a dip in brightness. The process took a staggering 20 years of observations with 3 telescopes, including Hawaii's W.M. Keck Observatory. Despite this long period of observation, we are yet to see the world complete a full orbit, with researchers estimating that this could take between 45 to 100 Earth years, probably 74 years. Ogle 2016, Yale G 1928, Going Rogue. Astronomers believe that the Milky Way could be teeming with cosmic orphans, exoplanets that have broken free of their parent stars to wander their galaxies alone. These planets are believed to form in traditional ways around stars, but are later flung away by gravitational interactions with other planets. Because exoplanets are usually spotted through the effect they have on their host stars, this makes these homeless planets almost impossible to spot. This is especially true when they are Earth-sized rocky planets. That's what discovers the rogue exoplanet Ogle 2016 BLG 1928 as it wanders the Milky Way so special. While it isn't the first rogue planet to be discovered, it is the smallest, with other examples much similar in size to Jupiter. The TOI 178 system, a system of harmony and chaos. At first glance, the planetary system TOI 178 may look like any other set of worlds. But a closer and more prolonged observation reveals that at least 5 of this system's 6 worlds are locked in a rhythmic dance with each other. The 5 outer planets exist in an 18:9, 6:4, 3 resonance. This means the first exoplanet in the chain, the second closest to the star overall, completes 18 orbits as the second in the chain completes 9, the third completes 6, the fourth complete 4, and the fifth, the 6th planet overall, completes 3 orbits. This means that the planets align at regular intervals as they orbit their orange dwarf host star. 55 Cancri e, the universe's most valuable exoplanet. Another star that orbits close to its host stars, taking under 18 hours to complete an orbit. 55 Cancri e is also inhospitably hot, reaching temperatures as high as 4,172 degrees F, 2,300 degrees C. But what sets this world apart is its composition, which makes the exoplanet, formerly known as Janssen, perhaps the most conventionally valuable object in the universe. The fact that 55 Cancri e is twice the size of Earth, but has almost 9 times the mass, led astronomers to propose that this super-Earth could be composed of highly pressurized carbon in the form of graphite and diamond mixed with some iron and other elements, according to NASA. Planets, black holes, extreme exoplanets. The most extreme exoplanets may not form around stars at all, but instead could orbit supermassive black holes. Planets form from the gravitational collapse of overdense areas of protoplanetary clouds of gas, of dust, and supermassive black holes at the heart of active galactic nuclei, AGN, sit at the center of massive churning disks of such materials. Currently, there is no evidence that such black hole orbiting planets, or blankets, exist, but recent research modeling the dynamics of these disks of gas and dust does suggest that under certain conditions planet formation should occur in such regions. Should such processes occur, blankets would form much further out from supermassive black holes than most planets do from their parent star, so distant in fact that it could take 1,000,000 years for such a world to complete an orbit. In conclusion, the discovery of these extreme planets is a testament to the incredible diversity of our universe. From the blistering heat of WASP 12 bits to the freezing temperatures of OGL 2005 BLG 390 ULB, these planets continue to fascinate and amaze us with their extraordinary characteristics. As we continue to explore and discover more about our universe, who knows what other incredible findings await us? So if you're as captivated by space and astronomy as we are, don't forget to keep following the latest discoveries and advancements in this field. If you found our video informative, kindly subscribe to our channel wondered what what lies lies beyond beyond our own solar system. Prepare to be blown away by the most extreme planets discovered so far. From scorching hot gas giants to frozen rogue planets drifting through the void of space, these incredible worlds will make you question everything you thought you knew about the universe. Don't miss out on this mind-bending journey through the cosmos. Watch the video. The more we learn about exoplanets, the more we realize the universe is stranger than we ever knew. Since 1995, our exoplanet catalog has rapidly expanded. We have now confirmed over 4,000 worlds outside our solar system, with a further 7,000 or so suspects waiting to be classified. Here are 10 of the most extreme planets we have discovered so far. WASP 76 bits, the exoplanet that rains molten iron. WASP 76 bits is a planet that is tidal locked to its parent star BD plus 01316. This means that one side of the planet permanently faces the star, causing scorchingly hot temperatures of around 4,532 degrees F, 2,500 degrees C, hot enough to vaporize iron. The star-facing side of WASP 76 bits is roasted by radiation that is thousands of times more intense than that Earth receives from the Sun, while the side that faces away from the F-type star experiences perpetual night. Yet even though the day side of the planet experiences hellish temperatures, that doesn't mean that conditions on the night side are a walk in the park. The side of WASP 76 bits that faces away from the planet's parent star is cooler by at least 1,832 degrees F, 1,000 degrees C, but this means that when iron vapor is carried across the hemisphere by powerful winds, they are cooled, forming liquid droplets. These droplets of molten iron then fall, bombarding the cooler side of the planet. HE 189,733 bits. Showers of molten glass. From space, HT 189,733 bits may appear to be a beautiful and tranquil world, resembling a giant glassy blue marble. With exoplanets, though, appearances can be deceptive, and this is the case for